Let's finish off our study of rational expressions by investigating square roots a little bit, seeing what they're all about. We've done a lot of things this unit. We've looked at fractions and ratios and all kinds of stuff. I can't even think of them right now. We're going to finish it off with square roots. We're going to learn a few things this lesson, 3 to be exact. I'd like you to remember what these 3 are before we start. The first thing we're going to look at is how to calculate the answer to a perfect square. You'll see what I mean once we get there. How to calculate the answer to a perfect square in your mind. Very fast, very quick. That's number 1. The second thing we'll look at is how to estimate the value of any square root expression using a very cool strategy. So estimation is number 2. The third thing we'll look at is real world uses of square roots, how they apply to the world, to make sense of them so that we're not learning it for nothing. Let's start right away here by looking at all these equations. I'd like you to write these down in your notes. And then beside each of them, we're going to write down the answers. So 1 times 1 is going to be 1. 2 times 2 is 4. 3 times 3 is 9. 4 and 4 is 16. 5 and 5 is 25. 6 and 6 is 36. 7 and 7 is 49. 8 and 8 is 64. You need to be quick with these. 9 and 9 is 81. 10 and 10 is 100. 11 and 11 is, what is it? 100 and what? 121. 12 and 12 is 144. 13 and 13 is 100. What is it? Come on. 169. And 14 times 14, you just flip these last 2 digits. You get 196. And 15 and 15 is going to be 225. Oops. Let's 225. Before we start, you need to memorize all of these. There is no time to waste to calculate them. You need to know them. Let me test you on them. If you think you've got it, look away from the screen and try to answer me as quickly as you can. I'm going to go very random with this. Ready? 9 times 9. 81. Question 2. 13 times 13. Okay, 169. How about 15 and 15? 225. 7 and 7. 49. 8 and 8. 64. 11 and 11. 121. That's your warm-up. Memorize them and get very fast at them. What are square roots? Well, the square root, it has a very interesting looking symbol. It looks like the long division symbol, except it's pointy at the bottom. The square root of 4 is going to be 2. Because 2 times 2 is 4. Likewise, the square root of 9 is going to be 3. Because look, 3 times 3 is 9. That's why we're memorizing these, so that we can figure out the square root instantly. These here are all the perfect square numbers, up to 15 times 15. These are the first 15 square numbers. So if I ask you, is 25 a square number, what are you going to say? You will say, yes, 25 is a square number. How about 5? Is 5 a square number? No. Only the numbers on the right side in green are square numbers. These numbers on the left are not square numbers, except for some of them, like 9 is a square number and 4 is, and because those numbers are also on the right side. If I ask you, is 100 a square number? What are you going to say? Yes, it is, because it's on the right side. How about 225? Yes, it is. You need to be able to recite all of these square numbers very quickly. So if I said, give me the first 6 square numbers, you need to, without even looking at this, you need to be able to say 1, 4, 9, 16, 25, 36. You need to be able to say them quickly, or at least think of them and figure it out quickly without wasting too much time. Let's do a couple more practice. What's the square root of 225? You look down here, you see 225, that's just 15 times 15, so the answer is 15. What we don't do is say the square root of 225 is 15 times 15. If you do this, that is completely wrong. You'll get the wrong answer. Don't do that. Just say the answer is 15. Here's another mistake people make. I might ask them a question like, hey, what's the square root of 8? And they say, oh, let's see, the square root of 8 must be, 4 times 2. Not only did they make the mistake of writing the multiplication equation, But they also made the mistake of, look at this. Look at the pattern here. The numbers are both the same. They have to be the same number. Here they pick two different numbers. Doesn't work. Here's another mistake. So this is wrong. Here's another mistake people make. I give them a question like, oh, square root of 6. And they say, oh, that's 3 because 3 times 3 is 6. Yes, they did include one number here, but 3 times 3 is not 6. 3 times 3 is 9. Right here. That's a mistake. It's an honest mistake. People make it. It's unforgivable though. So don't make that mistake. Why do we call it square roots? The story is I like the story of it because the word square or the word square root has two parts, square and roots. So number one, you need to be able to understand that these numbers belong to a square. So if we draw a square like this, these numbers represent the area of the square. The what? Yeah, the area, which is the space on the inside. So if I picked a number like 36 centimeter squares, and I said, what are the dimensions of this square? Now this doesn't look like a square. I know it's, let me make a better square. Let me make a better one here. One that actually looks like, a square. How about this one? Let's do that. If I said, okay, this square here is going to be, what was the number I picked? 36 centimeter squares. And I said, what are the dimensions of this? You would say it's 6 centimeters on the bottom and 6 centimeters on the side, because 6 times 6 gets you the area of 36. And since it's a square, all the sides have to be the same. You can't pick two different numbers. You can't say, oh, that's 18 and that's 2. That's 18 times 2 is 36. It can't be possible because squares have equal length sides. That's what square roots are. It's the dimension of the square with an area of whatever we say it is. Okay? Why root? If you break down the word root and you look at its origin in history, the word root means basically the origin of something. Where does that thing start? Like the roots of a plant are the origins of the plant, which is under the ground. That's where the plant begins. If you look at your own family roots, it's talking about your ancestry. Where did it all begin? Well, if we look at a square root, we're asking ourselves here the question, where does this square begin? In other words, to make that square, we need to have an origin. And the origin is these pieces, this piece and that piece and that piece and that piece. And all those pieces are going to be a root of that square. We just want one of them, the 6. Okay, that's the root of it. Here's another example. Look at this one here. I've got a square with 16 centimeter squares, which basically means that's the area. What's the root of this square? What's the square root of this? That's 16 centimeter squares, right? The root of it will be, just count them, 4 and 4. 4 and 4 is 16. 16 centimeter squares. I should write centimeters. So the square root of 16 is going to be 4. Look what I've got over here. I've got a multiplication table, and highlighted are all the perfect square numbers. I've got 3, 4, 5, 6, 7, 8, 9, 10. Very quickly, I'm going to test you on this. I'm going to circle one of these numbers, and you have to tell me the answer right away. Are you ready? 5. Good. How about this one? Did you say 9? How about this? Yes, 7. How about this? Ooh, 3. Got it. 8. Yes. Square root is, yes, you got it. 6. Square root of this is 6. How about this one? 4, 2, square root of 1. What is that? 1. Because if you have a square with an area of 1 centimeter square, what are the roots? What are the dimensions? That's a 2 here. 1 centimeter. Let's make that clearer. We got 1 cm with a 2 means square. What are the roots of the square? What are the origins? It's a 1 by 1. They're all 1s, right? So the square root is going to be 1. What happens, though, if we don't get a perfect square? See, 6 was not in our list. You can't give me a number multiplied by itself, a whole number multiplied by itself to make 6. 1 times 1, 2 times 2, 3 times 3, not 3 times 3 maybe. No, don't get fooled. 3 times 3 is 9. There is nothing that makes 6. So what you do is now if I asked you to calculate the exact answer, you just take out your calculator, you punch the square root sign and the number 6, you push the equal button, it'll tell you what it is. But I'm asking you here to estimate. No calculators required. Not allowed even. What you do is you pick the 2 closest square roots that you know, one smaller than 6 and one bigger than 6, and you sandwich it. It's like building a sandwich. The closest one that's smaller than 6 is the square root of 4. Square root of 4. We know that's 2, because 2 times 2 is 4. Square root bigger than 6 that we know of is what? Square root of 9. Don't pick 16, that's too big. 9 is the closest one on the large side. So we have this one and this one. This is 2, this is 3. Look, square root of 6 is sandwiched in between them. It's like the hot dog. It's like the patty and the bun. So its answer will be also sandwiched between these two. Maybe 2.5. You know what though? 6 is closer to 4 than it is to 9. So I'm going to say somewhere around maybe 2.3, 2.4, maybe something like that. It's just an estimate though. It's going to be somewhere in between. Let's try this one. In fact, you can try these on your own if you'd like. Let's see if we can sandwich this. What are we going to pick here for the smaller one? Think. 49. Yes. That makes 7. What about something bigger? Good job. Yes. I hope you said 64. I heard somebody say 64. That's going to make 8. So 52 will be somewhere between 7 and 8, but is it going to be closer to 8 or is it going to be closer to 7? That's right. It's going to be closer to 7 because look, 52 is so close to 49, but so far away from 64. So let's call it 7.1 maybe 7.2. It doesn't matter as long as it's reasonable. And the last one here, we need 2 numbers close to this one. Okay, let's see here. 12, square root of 144 makes 12, but there's something bigger. What do you think it is? How about the square root of 169? Remember what that was? What is it? Come on. Yes, 13. And the square root of, what is it? 196. Yeah, these bigger numbers take more time, right? Not if you know these quickly enough, then it's simple. 196 will be 14. Is this closer to this one? Or is it closer to this one? That one. So we're going to call it maybe 13.2, maybe 13.3. They're both good guesses. We've got 2 real-life questions that involve square roots. Here's number 1. A square bedroom has an area of 64 meter squares. What is the perimeter of the bedroom? There's 2 parts to this. Number 1, you need to draw a picture. Let's draw this square. We'll put a square here. I'll try my best to make it look like, oh, that's not bad. Oh, it's still rectangular. We'll pretend it's a square. We'll write 64 centimeter squares. That's the bedroom from looking at it from above. We know then the root of that square is going to be 8 centimeters. Well, no, actually, it's not 8 centimeters. What am I doing here? This is 64 meter squares. That'd be a small bedroom, you know, having it 64 centimeter squares. So we have our dimensions. It's 8 by 8. That makes 64. But now the question is, what is the perimeter? And the perimeter is, how far is it all the way around? And that's just going to be 8 plus 8 plus 8. Don't forget your units. Plus 8. That makes what? 8 times, or 4 times 8. That's 32. 32 meters square? Nah, you know why? Because we're just going around. It's just 8 plus 8 plus 8 plus 8. That's just 32. 32 meters. It's not area to say meters squares. And I think we've got our answer. Perimeter equals 32. Here's the last question of this lesson. The combined area of the land below is 64 meter squares. Okay. What are the dimensions of each of the smaller sections? Look, this is a little bit more challenging, but very similar to the last question in that ignore these little squares for now. The area of just the yellow is 64. Altogether, it's 64 meters squared. How long is each edge going to be? It's still going to be 8. 8 meters this way. It has to be 8 meters because 8 times 8 will make 64 meters squared. That's the area. That's the space in the middle. But here's what this guy has done. He has broken it down into 1, 2, 3, 4, 8, 12, 16 squares. And we want to know what are the dimensions of this and that. This and that. They're all going to be the same. So we just need to get just one of them. Look at this. Think about it. From here to here is 8. How much is each piece going to be? 2, 4, 6, 8. 2, 2, 2, 2. How about the side? Yes, the same thing. 2, 4, 6, 8. It's a 2 by 2 square. So what are the dimensions? The small square is 2 centimeters by 2 centimeters.